Alright, Math 1, we got sequences 1.3. So we are looking at some function notation and looking at explicit and recursive equations, okay? Now, if we remember our recursive equation, it's a sub n equals a sub n minus 1, and then the growth, okay, whether that's plus a number, minus a number, multiply a number, or divide a number. And then we have our starting, a sub 0 equals whatever that starting number is. Okay. Now, if we're looking at function notation is very similar. Instead of a sub n, it has f and then parentheses of n. So it would be f of n. So if we were to write that same recursive, it would be f of n equals f of n minus 1, and then plus, multiply, divide, subtract the growth, and then f of 0, like a sub 0, would equal that start number. Okay, so it's the same idea. So the number inside is like the term. Okay, what the whole thing is equal to, that's the output. Okay, so when we look at number 1, it says f of n equals 12. That means when the output here, f of n equals 12, what's the value of n? Well, 12 is right here, so n's value would be 5. So n would equal 5. So what is the value of f of n minus 1? Well, if n is 5, f of 5 minus 1 would be f of 4, and f of 4 is right here, 4 is right there, so f of 4 would equal 7. Okay, so that's all we're looking at here. Okay, number 2, f of n equals 17. Well, 17 is right here when n equals 6. So what is f of n minus 1? Well, f of n minus 1 would be f of 5, because 6 minus 1 is 5, which we know to be 12. Okay, again, notice 5 is the input, the output is 12. The input goes in here, output is what it's equal to. F of n equals 32. 32 is right here, so n is 9. Now this one says f of n plus 1. So f of 9 plus 1 would be f of 10, which is, 10 is right there, so it would be 37. Okay. Number 6, f of n equals negative 8. What is n? Well, negative 8 is right here, so n is 1. F of 1 plus 9 would be f of 10, which we already know is 37. Okay. Number 5, f of n equals 27. 27 is right here, n equals 8. So f of n, or 8 minus 6, 8 minus 6 is 2, so f of 2 would be, 2 is right here, f of 2 is negative 3. Okay. Then we've got f of n equals 2. 2 is right here, so n is 3. What is the value of f of n plus 3? So f of 3 plus 3 would be f of 6, which is, 6 is right here, and we know it's 17. Alright, so that's kind of that function notation and how it's kind of connected to the sequence notation. Alright, now we're going to kind of compare some explicit and recursive equations. So we're trying to decide which is easier, the explicit or the recursive equation. Now we could rewrite these explicit equations as a sub n equals 3n plus 7, and the recursive would be a sub n equals a sub n minus 1 plus 3. Okay, so you can rearrange them if you want, but you don't have to. Alright, so this first one, we've got an explicit equation, y equals 3x plus 7. We've got our recursive, a sub n equals a sub n minus 1 plus 3. We want to find the fourth value. Fourth value is right here. So our question is, which is going to be easier, the explicit or the recursive? Okay, well, the recursive, we'd have a sub 4 equals a sub, let me actually give myself a little more room. Have a sub 4, because we're looking for the fourth term, equals a sub n minus 1, n minus 1, or 4 minus 1 would be 3, plus 3. Okay, well, a sub 3 is 16, so a sub 4 equals 16 plus 3, which is 19. Okay, so that's the recursive. Let's see the explicit now. So I'd go y equals 3 times 4 for x plus 7. 3 times 4 is 12, plus 7, 12 plus 7 is 19, which we knew that's what it would be. Okay, so now we have to decide which one's easier. Okay, I think probably the way we wrote this seems like both of them could be pretty easy. But if we didn't write this down, I think it would have been easier to use the recursive and realize we're just adding 3 there. So the recursive, because we're just finding the next term. Okay. Now let's take a look at number 8. So now it's got the same explicit and same recursive equation, but now we're looking for the 50th term. So if I'm using the recursive, a sub 50 equals a sub 50 minus 1, or 49, plus 3. Okay, so a sub 50 equals, now do we know what a sub 49 is? We don't. Okay, so we'd have to go start clear back from 2. Okay, so I think we can see right off the bat that one's not a very good idea. So let's try the explicit. So 3 times 50 plus 7. 3 times 50 is 150, plus 7 is 157. So the 50th term is 157. So I think we can pretty easily say it's the explicit. Okay, because, we didn't need the 49th term. Okay, which meant we didn't need the 48th, or the 47, or the 46, or the 45, 44, so on, until we got back to 2. Alright, let's try number 9 now. Okay, so 9 and 10 says the value of the 8th term is 78, and the sequence is increasing by 10 at each step. Okay, so we've got y equals 10x minus 2, and our recursive we could rewrite as a sub n equals a sub n minus 1 plus 10. Okay, and a sub 8 equals 78. So the 20th term. So if we went a sub 20, or find the 20th term, it would be a sub 19 plus 10. We don't know what a sub 19 is. Okay, we don't know that 19th term. So I don't think the explicit's very good. Or the recursive. Let's try the explicit. Y equals 10 times 20 minus 2. 10 times 20 is 200, minus 2, 198. Okay, obviously it's the explicit. Okay, the reason, because we don't know what the previous term is, so it didn't work, did it? Alright, now looking at find the 9th term. Okay, so a sub 9 would equal a sub n minus 1, so that would be 8, right? 9 minus 1 is 8, plus 10. Do we know what a sub 8 is? It is. It's 78. 78 plus 10 would give us 88. So our answer is 88. Okay, we could do the explicit. 10 times 8 minus 2. 10 times 8 is 80. Minus 2, we get 78. So what happened here? Shouldn't we be getting the same answer? Okay. Well, I think I figured out what our problem was. Okay. Our starting number was actually not the first term. Okay. So the problem here is that the 8th term is 78, okay? So if we were to make a table here, and the 8th term was 78, if we're going back by 2, or by 10, the 7th term would be 68, then 58 for the 6th term. 5th term would be 48. The 4th term, clear some space here, would be 38. The 3rd, 28. The 2nd, 18. Oh, duh. No, we'd go back and get the 0 term. I'm an idiot. I meant to put 9. Simple fix, huh? Okay, we got to watch for those silly mistakes like that, because we all make them. So 90 minus 2 would give us 88. There we go. So obviously the recursive was a lot easier in this one, because I messed up the explicit. But this idea is that since we were just going off that previous to get to the next, that's the explanation as to why it's better. Alright, let's see if we can not make any mistakes on the last two now. So it says the value of the 4th term is 80, so a sub 4 equals 80. The sequence is being doubled at each step, so a sub n equals a sub n minus 1 times 2. Okay, find the 5th term. Well, we should have recognized by now we have the 4th term, so just take 80 and double it. 80 times 2, 160. Okay, I could use the explicit here. Go y equals 5 times 2 to the 5th. Okay, 2 to the 5th, 2 times 2 times 2 times 2 times 2, 5 times. And it's also multiplied by 5. So 2 would be 4, 2 times 2 would be 8, times 2, 16, times 2 would be 32. So then I go 5 times 32, and we get 160. Obviously the recursive, because we knew the previous term, so to get the next term, it's very easy when we know the pattern. Okay. Then finally, to find the 7th term. Okay, so to find the 7th term, we would need the 6th term, which means we would need the 5th term. Now we know the 5th term, so I could just go 160 times by 2 to do 320 times that by 2. So 320 would be the 6th term, times that by 2 and get 640. And it wouldn't be too bad to make a table and kind of go that way. So the recursive could still be fairly useful because it's pretty close. And we could also try the explicit. So 2 to the 7th means we have 7 2's instead of 5. Okay. Well, we know that 5 of these make 32. Times by 2 again, we get 64. Times by 2, we get 128. Times that by 5, and we get 640. So in this one I think either, because it's not too far away, so using the pattern isn't too bad, as well as using the explicit equation. Okay, so kind of main idea here is that if you have a term that's a long ways away, and you don't have any of the previous terms, the explicit is typically your better bet. But if you have just a few terms close together and you know some of the ones previous, recursive can be really easy too. Alright, there we go.